Welcome to Stack Sessions. I'm Jeff Keyes, Field CTO at AllStacks, and this is where we explore the intersection of software engineering and business strategy, particularly how AI is transforming development teams and engineering leadership. In each episode, I sit down with engineering leaders, investors, practitioners, and industry experts to navigate the real challenges of building and scaling teams in this AI era. We go beyond the hype to talk about what's actually working and what it means to lead engineering organizations when the fundamentals keep shifting underneath us. Today, I'm really excited to be joined by James Kaplan, partner at McKinsey Company, where he advises CIOs and CTOs on technology strategy and has been writing and thinking deeply about the new economics of AI-enabled development. James, welcome.
Thrilled to be here.
I am more than excited to be here, but just to kind of kick us off, how did you get here?
Okay. Define here.
Well, we're
At
at
this
an
point in my
intersection.
career?
Yeah,
Yeah.
well,
Okay.
we're at an intersection of the industry now where so much is changing. And I love that you're taking the business side of the change and influencing where leaders are doing things. How did this end up being your passion? How did you end up in this career where this is now where you're helping people?
It was all by accident, just to be very clear. Sometimes people are surprised to find out I was a history major in college.
Hmm.
Although I was also the kid at the age of 12 or 13 wrote a word processor on his VIC 20. Um, yeah, but for whatever combination of reasons, I didn't want to be a computer science major in college. I spent all my time not going to class and being editor-in-chief of the Brown Daily Herald, which was a fascinating experience. I actually wrote about that in Prosaic Times because the Herald, given a couple of my predecessors, was early in desktop publishing. And we had actually a really interesting and complicated technology-enabled production process. So I
Hmm.
wrote about how we finally succeeded with Project Midnight and got the paper to bed at midnight rather than at 3 o'clock in the morning, which allowed everyone to get a lot more sleep. So, having a history major, I decided I didn't want to go to law school. That was sort of like what you were supposed to do if you're a history major. I graduated in the early 1990s. It wound up. I decided I didn't want to go into journalism. Caught on with a startup doing new media type things in Boston in the early 1990s. And eventually I came to play a sort of chief technologist role there because I found out that older people more likely to listen to younger people about code than about
Hmm.
copywriting or design. And we did all sorts of fascinating stuff on things like CD-ROM based publications and catalogs you could put on a disc and demos and things like that. It was a much more archaic technology environment trying to get stuff onto 720K floppy disks and fit into 640K RAM windows and on a 640 by 480 VGA screen. After a while, it became clear that this company was only going to go so far. So I went to business school at Wharton and majored in finance. I got really interested in telecom, and I had a professor there who later, Jerry Fallhaber, who later went on to become chief economist at the FCC. I went to go work at Deloitte for a couple of years, did a lot of stuff in telecom there, and then got recruited to come to McKinsey as they were starting to scale the technology practice. And
And and you've been there for a minute.
I'd been there for a minute. I've been there for going on 26 years. Let's see, I joined in 1999. So yeah, no, it'd be 27 years in December. This
Wow.
coming December will be 27. That's slightly terrifying. Yes, I terrify associates by recounting tales of the days of like fax machines and dial-up modems and hand-drawn slides and things like that.
Yeah, I too have adult children with very interesting questions they ask about where do the stickers come from that you put on the letters, and how do you get the stickers for the back of the car, and what is it? Yeah, we can go on and on about that.
Yeah,
Hey,
I
diving into this.
yeah,
Um,
I sometimes, yeah, my kids would get bored when I explained to them, gee, we only had like a few television channels when we were kids because we didn't get cable in Old Tappan, New Jersey till I was about 11 years old or so. But
oh yeah,
yeah,
I,
fun times.
uh,
Eh,
and did you ever have to adjust the antennas on the top? And what are those things for? It just boy, oh boy, oh boy. Yeah,
you know,
we've had some.
had the reception was okay. We had an antenna on the roof
Mm,
of our house. I remember my dad, sort of like, well, I remember watching, I must have been, 7, 8 years old or something, when my dad watching around and putting an antenna on the roof that could provide signal for all the TVs in the house.
I love it. I love it. Well, before we jump into
Yeah, all
AI,
right. All right.
let
Yeah,
me
there's
hit a
another bunch of years in there, but but let's not go into that. Let's just get into the content of this. Or
well.
we could just reminisce about the 1980s, 70s, and
Oh
80s.
man, I and it'll go on and on.
I'll share just one other thing. I was on a panel with a very impressive set of young founders the other day, and by young I mean not 35, I mean 20. And they were all talking about how they were playing with iPads as kids. I'm like, the iPad
Wow.
came out when I was 40.
Okay, now I
Let me
feel
explain
like
the
I
RF
should.
modulator to you guys.
Yeah. Ay, ay, ay. Well, before we get into AI, though, I want to start with something that you've written about that most people don't talk enough about. You know, infrastructure costs have utterly collapsed in essence over the last 20 years.
Yeah, 30,
But
I'd say 25, 30, since the turn of the century, say.
yeah, but what's interesting is that there's been no real comparable improvement in the actual productivity of building software. Double click on that. What's
Yeah.
behind that?
Well, a couple of things. One, you you have less of the tailwind from Moore's law in software development engineering than you have in infrastructure. There is, to some degree, in infrastructure, we were riding a wave of hardware innovation and innovation at the chip level. Second, there's a degree of abstraction in infrastructure. It's less idiosyncratic by business process, so companies were able to consolidate it and automate it. And third, it's a hell of a lot easier to measure. In infrastructure, we have volume metrics we can talk about, per socket, per OS image, per port, per circuit, and that's harder to do. And therefore it's it's harder to do at the application software level. And
Hmm.
therefore, it's harder to improve things which are harder to measure. The other thing I would note is we've had, countervailing effects that I think have impacted the application layer more than the um the infrastructure layer. We've had a massive increase in our level of expectation about user experience and user interface. We've had a massive increase in our level of expectation around resiliency, around the complexity of the application. In many industries, there's been a massive increase in regulatory requirements, certainly in financial services. This goes somewhere in the past, but there was, one year that, a credit card business I know have spent its entire application development portfolio complying with the Card Act, right? So that, I don't know, that's a good thing or a bad thing, or it was just a necessary thing that
Right.
that costs money. And obviously, more expectations around cybersecurity. So our applications, I think, are more complex than they were, 2 or 3 decades ago.
Absolutely. And there's always been this expectation in writing software that um, the hardware will always just improve
Hmm.
and it will get cheaper and faster. Therefore, the pressure hasn't really been on the software. I mean, sure, productivity, but individual teams have often written in advance of what hardware to come. You look at the gaming industry and all that that has expected on. My neck of the woods, we've got Valve, Bungie, and EA, bunch of stuff around here, right? And it's always been the case, just waiting for that to go.
Yeah.
Against that backdrop, what makes today interesting is AI-enabled development. You were writing that, this is particularly, maybe this is the first time that that equation is gonna change.
I won't say the first time. I'll say the first time in a while. Okay. And I'm old enough to remember as a spectator, not as a participant, the shift from assembler to third generation languages. For example, there was a um, giant controversy. I guess it was in the early 1990s when Lotus Development Corp wrote 123 version 3.0 in C
Yeah,
rather
I remember it.
than assembler. And all the old heads were, no, this will never be performant enough. It's, that
Yep.
type of thing, right? And no, and obviously that may have, there may have been other issues that Lotus 123 had. I think technically they were able to write it in C. So to me, this is to me, this is almost the next layer of abstraction. So we've gone from machine code to assembler to, really second and third generation languages and so forth. I don't even like the term AI enabled development sometimes. Sometimes I think spec driven development is a better term because we're still programming. We're just moving from procedural language to declarative language.
That's a good call. That's a really good call. So, what is it that you think you said this isn't necessarily the first time, but is this time different? And if so, what do you think is going to happen out of it? How big of a change is this going to be? Or is this are we ever gonna get to Moore's Law like hardware has been through?
Eh, we won't get to Moore's law. I mean, I is this time different? Well, I'd say the previous couple of times were pretty big. You know, when we went from machine code to assembler, that created an industry, and we went from assembler to higher level language. That created, you know, there's been a lot of change since 1990 in terms, this is in terms of technological adoption development. So I don't know if it's different or bigger. Maybe it is. It's a little bit hard to say, but I think I think it's quite I think it's quite significant. Right now, the challenge is, as with all of these changes, it will require operational change,
Mhm,
not just technological change.
mhm.
And here's what may be most different, which has come. We still had listen, you didn't have the genius solo developer quite as much in 1990, but the development teams were a lot smaller and less complex. So we're m- moving from a change, or generationally, the difference is it's not a change that requires change for an individual coder or an individual development team, but across an ecosystem that, whether you're talking in a technology company or in an enterprise.
Absolutely. Another aspect of this, you brought up, Jevons paradox in this context where, if you reduce the cost of something, you actually end up getting more of it, not less.
Reduce
Um,
the unit cost.
Reducing the unit cost. Correct.
Yeah.
Well, what do you think this means practically for engineering organizations? Like you said, typically we started with small, went to really, really big, and now what's going to happen here?
Yeah. I couple of thoughts. One, some of my colleagues at McKinsey talk about a smaller squad. I think that's, from say two pizza team to one pizza team. I think that's very true. I think you will have, sometimes I talk about an I-shaped model where instead of having one senior person and a larger number of more junior people, I think we'll see maybe more of a master artisan and apprentice type of model, or small number of apprentices type model. I think it will make, in certain respects, software engineering harder. Here's what I mean by that. So I was talking with a computer science professor, and he was pondering whether his department should be teaching agentic development or the core principles of computer science or what have you. And I think that with spec-driven development, many of the important principles remain, and we're getting rid of the syntax, which is, and I think we're already seeing in some places for the cutting edge teams, a degree of, wow, it takes a lot of intellectual effort to stay on top of a fleet of coding agents.
Yes, it does.
You really have to think hard about what they're doing and whether they're adherent to the vision and the architectural principles you're trying to pursue.
Mhm. Yeah, yeah. Because you have to understand so much more of the entire process, and you have to understand the implications of what's being produced in the context of what already exists. Um, and there's sort of, it feels like, as I've talked to customers and people in the industry as well, there's a lot more blurring of some of the roles as well. A product person is now checking in code because they can.
Yeah, I mean, I in one of my pieces, I talk about the creation of strats, right?
Yep.
We have the, the folks are they a trader or are they a software engineer? We don't know, right?
Hmm.
Um, the one thing which I agree with, that will necessarily come to pass. I think much of the discourse has focused on this as sort of a simplistic way, which is, oh, we'll have non-technical people checking in code, which I'm sure will happen. But I wouldn't make the assumption that the blurring will be only not non-technical people doing technology. It may be easier to teach engineers about the business domain than to teach non-engineer marketing or other people, you know, to engage in spec-driven development effectively.
Hmm. Yep.
And certainly we saw that in certain places in the creation of the strats. Many of those folks were not bankers. They started out as software engineers and they knew the algorithm so well, right? They in effect learned the trading strategy by coding the algorithms.
Hmm. Yep. And that's
And,
the way to do it.
and then
Um,
I expect if we roll the clock forward a few years, you wonder if it will become more natural for a knowledge worker, for a professional to have to naturally have more of a mix of skills. And part of the reason I say that is my own experiments using Cursor and Claude and what have you to automate my professional life, and the ability just to engage directly with the data rather than through an application is a tremendous accelerant.
yeah. I think while we're talking about software, the impact to every white collar job, I think, is going to be, this will be the year where we start to see some more influences of that, in my prediction,
Exactly.
um, in a much
And
bigger way.
the two things are related because most people with white collar jobs use a lot of software
Correct. Right? Yeah.
in
If
one form or
it,
another.
it's almost like I want to say to the world, like, if you find yourself using a bunch of spreadsheets, get ready. If you find yourself using some old stodgy application and you're waiting for a year and a half pipeline of waiting for somebody to go fix it for you, get ready, because
Yeah.
all that's going to change. Which,
Yeah.
really this gets us into one of my favorite topics that you have, which is, the IBIT equation, where value actually leaks. You've modeled how technology investments actually translate or doesn't
Or
translate
trying
into
to
an
model
EBITDA
or in the
lift.
process of modeling.
Try.
Yeah.
Can you,
So a little bit,
like,
yeah.
this is like one of the coolest things. It's a great way to think about how do these pieces fit together. Walk us through this
Okay.
modeling, this equation.
Yeah.
I don't
So
think enough people have thought about what they do in this way.
okay. So why do we invest in technology projects? Okay, some things we do because we have to, regulatory compliance, but we do it because we have a hypothesis that will increase the profitability of the institution, say by increasing EBITDA. And then, so let's assume, I think that's a true assumption based on observation. Every company faces a pipeline of potential projects. right, that they could invest in. And the these projects, you can stack rank them, the highest one first, and then you get a declining ROI, right? For each project, each thing is, a little bit less profitable than the next thing, and you get an ROI curve. And I learned stuff like this in my first year finance class at Wharton. And so what you want to do is you want to be able to go as far down that ROI curve as possible, right? Till the point where your ROI equals your hurdle rate. So how do we think about, what generates ROI? My point is that, okay, business driven investment is correlated with the EBITDA lift, but there's some adjustments you have to make. First of
Hmm.
which is you have to adjust for value leakage. Sometimes we invest in the right projects, and sometimes we define good requirements, and sometimes we don't.
Yeah, what? Right.
And, even the best company is going to sometimes define bad requirements or sometimes invest in bad projects or projects that, are not fit with their business strategy, right? And, sort of reducing that value leakage percentage from 30% to 10% has a lot of impact. Second thing is we have dead weight loss. And this is a lot of where the spec-driven development comes in. A lot of what developers do is, you know, dead weight loss is not correlated with functionality that users will can take advantage of. There's
My
rework,
my
there's
favorite
time
phrase
spent
is
in
yak
meetings,
shaving, I think is one of
yak
them.
shaving, right?
Yeah.
And what's more, you could argue that the emergence of spec-driven development has pushed the frontier in terms of what's dead weight loss versus not. And then third, you have adoption loss. And I've seen very many places where people have rolled out actually pretty good software, and the users won't use it. No, no, no. I have this spreadsheet here, which I like a lot, and I understand, and I'm going to keep using that. Or they use it, incorrectly or inappropriately and what have you. And again, so if you can reduce adoption loss, that has a tremendous impact. And, if you assume, say, that you're 70% right on your requirements, and you assume that, sort of 50% of your engineering labor is focused on actually creating code, and you assume that, 70% of your users use the product well, you multiply that all through, only a relatively small percentage of your investment dollars generate return, which means you only go so far down the ROI curve.
Yeah. I love the equation because I'm in an industry, right? We're all in this software industry where we have a massive amount of data on what's happening. We look at
Hmm.
speed. Every executive says, I need to produce faster. Go get this team running better. I've got set of industry standard metrics that are best practices.
Hmm.
Gosh, fix your DORA metrics. Go look at your value stream flow. Go put these things together so we can deliver more stuff faster. But back to the equation, you said like this dead weight loss is a lot easier to address, and to translate that to what every engineering leader needs to understand is really you're talking about focus and making sure they're building the right things.
Yeah, I mean, a couple of thoughts. One is many of the metrics you said are, I would say, components of dead weight loss. It's part of its focus, yes. And part of it is the ability to communicate to the executive team. Because part of one of my core beliefs is that part of the reason I built this model is tech for tech investment is valuable. And I think companies in many cases underinvest in tech for tech. Be, because it takes longer, it has a longer time horizon, and it's hard to explain and hard to quantify. So I think there's a big difference between saying we're going to invest in tech for tech. That is going to reduce dead weight loss.
Hmm.
Okay. You're going to give up something this year, but you're going to get a lot more in the out years because dead weight loss going forward will be much lower. And then on things like value leakage and adoption loss, it's often hard to get business users to engage on certain things. It's probably better than it was 10 years ago. And certainly the focus on AI has increased engagement. But I thought it would be helpful to try and quantify what the impact of not getting of the operational team not showing up for the requirements meeting or underinvesting in operational change management could be.
Mhm. Yeah, which is so spot on. I'm glad you brought up the tech for tech because especially in today's world, I don't no organization can effectively adopt AI without adopting more tech for tech. And it's a shifting
Some are
sands of
trying.
what
Some are
yeah.
trying. And
Yeah.
this is what I call the tyranny of the use case,
Yeah.
which is, we're gonna have, every mid-level manager has his or her use case that he or she wants to use AI for, reduce churn over here, increase retention over there, increase, and reduce service time over in the third place. And wants to, in many cases, there's an inclination to do these things separately on an independent technology stack. And I think of it like trying to get to the moon by climbing the tallest tree. The first 60 feet feel fantastic. And then they're like, oh, gee, where do we go from here? Because you're creating a lot of technical debt. And you're from a business strategy standpoint, you're not integrating across use cases to transform a business domain. Because if you're going use case by use case by use case, I would suggest you're undergunning the level of business change that you could achieve in many places.
Absolutely. So, let's talk advice here then for the engineering leadership, product leadership of companies as they look at their software investments. How do they actually how what changes should they make to how they're following value in the world of they have all this data rich kinds of things? What should they be looking at to understand how well are they measuring this dead weight loss aspect?
I think it's the best way to do this is via experimentation, right? It's easy to say, I'm not sure about spec driven development and I want someone to prove it for me. I worry that those who engage in that strategy will find themselves left behind. If I were a CTO, I would be picking some number of teams, big teams, not just experiments or not just small experiments, converting them to spec driven development, which means changing their operating process, putting an integrated tooling stack in place, um, upskilling or reskilling some of their people, and measuring how much you get out and how much downtime there is. So you can say, okay, gee, I'm not going to show you, a blog post or a magazine article. I'm going to show you the rest of the institution. I have this team operating in this way and these other teams operating in that other way. And here's the difference between the two.
Yeah. Perfect. Perfect. Let's
Yeah.
switch
And
gears.
this is, let me just,
Um,
this
okay.
adheres to a suggestion I've made for many years. It's more powerful, in a enterprise-wide change program. It's more powerful to change everything someplace rather than something every place. Get at least one piece of the organization working in the new way.
Mhm. Yeah. That way, at least if something goes wrong, you can adjust versus having to rechange the whole organization.
Well, A, you can adjust. B, you can't change everything every place. So put you implement a set of mutually reinforcing levers, and it's much easier to measure the benefit and therefore communicate it to the rest of the organization.
Right. Yeah. And then to your point, there'll be some success factors and some learning and some experience of
And
actually
then
achieving
you
better.
roll it out to the
Yeah.
rest of the engineering team.
So this is spot on with our next topic. There's a report from McKinsey that shows that 88, that shows 88% of teams having AI adoption, but only about a third are actually scaling AI in their development practices. When you first saw that, your reaction was essentially, "Well, what did you expect?" Um, Help
Yeah, well,
unpack
I mean,
that.
there's two things here, two dynamics we need to tease apart. There's been, oh, I don't know how many reports about AI. I see AI everywhere except the bottom line, right?
Right, right.
It's like, okay, a scale of this change in I mean, what are we, 2 years in? A scale of this change in magnitude and complexity is not going to be transforming, the operating income of the institution in 24 months, right? This is a generational change we're engaging in, which doesn't mean you should be patient on returns. You should push hard for them, but there is some degree of correlation between the scale of change and the time and effort required, or the scale of the benefit and the time and effort required to achieve it. Now, there's a second dynamic which I would say is more worrisome, that many people are experimenting but not scaling, which is, and sometimes that's correlated with the use case disease. We have a use case over here and a use case over there, and we're letting this grow organically rather than in a systematic way, trying to change the way that, first business domains and the entire enterprise operate.
Mhm. Yep. Well, take this back through the EBITDA lens. When organizations adopt AI coding tools and see, as you said, small teams and pockets writing code faster, but they're not showing enterprise level financial impact. Is it they're building the wrong things? Is it they're not doing
Well,
spec
I
driven
mean,
development?
if small teams, if you have a $50 billion company, you know a few hundred engineers adopting spec-driven development is not going to change the bottom line on that company, right? So the first issue is scale. The second issue is, time, right? Which is the, certain investments you may make now may take some number of years to pay off, particularly if it's things like new products, right? Rather than, a change in pricing strategy or what have you. And then third, it's like, okay, is this just an engineering team someplace changing the way it's working inside the four walls of engineering? Or are the folks in other business functions, marketing, sales, operations, supply chain, what have you, engaging with them in a different way and being creative in how they're putting AI to work?
Yeah, I I love it. Following this along, there's data from a large financial institution showing that code review time for teams is changing quite dramatically in this, jumping from 10% to one-fourth of developer time.
Hmm.
Dora research is showing that AI adoption actually increases change failure rates and rework. So, give me your take. Is this is this helping, hurting our dead weight loss? Or as
I'm
what do you
I'm
think?
sure all of the above, right? And let's say the transition from assembler to higher level languages wasn't without its bumps and problems as well, right? So, a couple of reactions. First of which, I'm not surprised, especially at the beginning, that people are spending more time engaging in code review, right? They're learning the process, and they're learning what they need to look at versus not look at. Second, you know, there's an art to spec driven development, which I think, quite frankly, we're discovering as a domain in real time.
Right.
And now we do have some evidence from the technology industry where some very elite engineers are saying, I don't look at the code. Now, that's a bit of an extreme situation, and may or may not be translatable to the enterprise in every circumstance. But you have to believe there's going to be some transition effects as we move from one model of developing software to another and potentially far more productive model of developing software.
So spot on. One other thing, you had a portion of a piece that you talk about six imperatives, and six imperatives to make the case in applying the right AI economics that
Hmm.
could dramatically impact it. Can give us a quick flyover and point us to some of that so we can come follow that better.
one of the there's a lot of inclination in companies and technology functions to think about one lever. We do this one thing that's going to change things.
Right.
And
Everything will be
I,
different.
I'm sorry, everything will be
No,
different, right?
yeah, exactly.
Yeah. And I would say that that doesn't really reflect reality. You know, change happens via a reinforcing set of mechanisms. So in the article where we first talked about, the economic modeling around EBITDA was, we also talked about, okay, gee, what did we think the imperatives would get there would be? And there were six we laid out. Um, first of which was really getting mature about the product operating model and really empowering product owners for each area, really understanding unit cost and a unit cost and volumes. Second, moving to a different talent model, which was really might be called spec-driven development, although we didn't describe it in quite that way. Third, you know, building semantic layers and moving from siloed data in many cases to building knowledge graphs. And there's been a lot of debate recently around context graphs. I think there's um yes, very interesting things there. But to me, the larger point is we have to think more about how data is interconnected and what it means taking advantage of differences in vendor taking advantages of differences in the or changes in the vendor landscape, so companies could make sure that they could retain a fair share of the value vis-a-vis their vendors in the technology space, reimagining risk so that they were able to both build AI to reduce various types of technology risk, and they could build the platforms to deploy AI at scale in a responsible, in a safe, and a secure way. And then finally, rethinking the technology architecture and accelerating the use of AI-based refactoring tools to reduce technical debt and get to a more composable technology architecture.
Um, Thank you. That is a great flyover and so much to unpack in that. I wish we had more time. If you haven't seen that, I would suggest reach out, find it. I don't know if there's a way we can leave a link to it, but
I can
great.
give you all the links. Happy to.
That would be fantastic. That is, I think, required reading for um, anyone who owns a product delivery in today's world. James, this is exactly the kind of conversation I was hoping we would have. We don't talk about the business enough of software. And the fact that we're using business terms like EBITDA is exactly the point. We as an industry need to stop thinking about AI as a productivity tool and productivity gains and looking at developer productivity and thinking about this AI shift as an economic one. I love your math of deadweight loss. You had another phrase about will the cats eat the cat food? Or are you delivering the right thing? All the right things that are
I
looking
try to
at.
write vividly so people
Yes,
will remember it.
it's so spot on. I love your influence, and I want to thank you for being here today. This is real things that you should be taking away if you're listening to this as part of your job to think more from a business context. You will never go wrong about talking about the value, the loss, the lack of focus, the more important than efficiency gains. Um, but to that point, James, how do people follow you? Tell us a bit about how we keep up with the amount of writing that you do.
So, some things I publish under the McKinsey flag, such as the triple the return article. And, given the pace of change, I've also started blogging at prosaictimes.substack.com. And I have great fun on publishing on that. And I encourage everyone to check it out. You can find it on Substack, and also you can sign up for the LinkedIn newsletter.
Fantastic. Highly recommend you do that. There's some great content here. James, what a pleasure. Thank you for joining us on this Stack session. Hopefully, we'll get to continue the conversation in a future session, and we'll put a bunch of links to everything in as part of the podcast. And until next time, my name is Jeff Keyes. Thanks, James. Until next time.
Thank you.